I am Sakni Kumar. I am doing my MTech from IIC Bangalore. So today I am going to discuss with you a second order transfer function with no resistance. Okay, means that kind of transfer function. So for this I am going to discuss means like step response, impulse response, and bode plot. Okay, so just see. See, for the second order, simplest transfer function is like look like h of 0 means a DC gain divided by 1 plus s by omega naught square. This is nothing but a resonance frequency. Okay, resonance frequency. Okay, so for example, if you take L, C, and here you want to give like this means impulse signals or impulse step, whatever you give for that. If you want to calculate what will be the output, how it will look like, so for that I will going to discuss. Okay, so see, for that here what will be the omega naught is equal to 1 by under root LC, or either you calculate like this, this is the Z, this is the Z. When Z is equals to minus Z, then it will look like infinite. So at resonance it will look like infinite. So this is SL equals to minus 1 by SC. So S square is equals to minus 1 by SC. So minus LC. So omega naught is equals to 1 by under root LC. That's how you calculate the omega naught. Okay. So after that, if you see the bode plot for this transfer function, then in the bode plot, see, for the low frequency, how it will look like? It is for the low frequency, it is h of 0 means DC gain only, and for the high frequency, how it will look like? For high frequency, it is look like h of 0, and this term will dominate. So s upon omega naught square. So it will look like h of 0 omega naught square 1 by s square. Means if you put s is equal to j omega, then it will become minus 1 by omega square. Means the phase will be minus 180 degree, and the magnitude will be h of 0 omega naught square 1 by omega square. Okay, this will be the magnitude. Minus means minus 40 dB per decade. Where? At the high frequency. So see, at the low frequency, the gain will be h of 0 means 20 log h of 0, and at the high frequency it will become 40 dB per decade. And at the omega naught, what will be the amplitude? So at omega naught, if you see, then at omega naught, h of 0 divide 1 plus s, you put j omega, then it will minus omega by omega naught square. So if you put at omega equals to omega naught, because you want to find the magnitude at omega naught, so here you put at then it will be real pole. It will be the real pole. So it will give infinite magnitude of gain. That's why it's gone up to the infinite at the omega naught. Okay. So for this transfer function, the bode plot will be look like this. Okay. After that, if you want to find the impulse response, means you feed an impulse signal to this transfer function, then what will be the impulse response according to you? Then see, just for the for the delta t, Laplace will be 1. So if you put 1 here, then y of s will become a transfer function itself. So for this transfer function, if you calculate in time domain, then you will find h of 0 omega naught sin omega naught t into u of t. So it will be the your output of impulse response. This will be the output for the impulse signal. Okay, so if you plot this, then it will look like this. H of omega naught, h of 0 and omega naught means d secant into omega naught or sin omega naught t into u of t. So for the step response, you just integrate to the impulse response and you will get step response. So see, for the integration of this, you should know some basics. For example, see, for the sin t, if you saw, then this will be the area will be 2. For example, you see any signal, if you want to find the area x of t, then let us suppose this will be the k. Then if you means scale in time, then area will get divided. Okay, I will use this concept here. So see, for the sin t, this will be area will be 2. For this means here it will 2. If magnitude is h of 0, then 2h of 0. Then if you scale in time omega naught, then area will be 2h of 0 divided by omega naught. Okay, area means, area will be this for one cycle. So see here if you see, then the this a amplitude is here h of 0 omega naught. This will be the this is the magnitude of this signal, amplitude of this signal, and after that if you see the time scaling is omega naught, so area will get divided for the half cycle is by omega naught. So omega naught will be gone, means area of h of 0 and whole area is multiplied by 2. So 2h of 0 means for the half cycle area will be 2h of 0. So if you integrate, then integration is nothing but to calculate the area of this plot. So if you see then from here to here area will be 2 of h of 0, means you go up to 2h of 0, and after that you are in the negative direction, area will be same, so you will go to 0, and after that it will look like this. Okay, so see, for the step response I already told you, you just integrate to this waveform and you'll get this waveform, and after that if you want to write in time domain how it is look like, so see, this is the step response, means y of t. So first of all, you just any waveform is look like, if there is some sine signal and some DC value, then just you write DC value plus this AC part. You can write like this. Okay, so here if you see the DC part will be h of 0. So I write directly DC part will be h of 0, and after that if you want to write this signal, so it will look like this. Okay, this is nothing but minus cos omega naught. So for the cos omega naught to this, and if you reverse it minus, then it will become minus cos omega naught t. So here it will be the amplitude will be h of, because this is difference between two, will be the amplitude of the cos omega naught t. So amplitude will be h naught, means h of 0, and your AC signal will be cos omega naught t. So total your step response will become h of 0 minus h of 0 cos omega naught t ut. So if you simplify this, then you will get h of 0 outside and 1 minus cos omega naught t into u of t. So can I remove this? So h of 0 1 minus cos omega naught t step response for this transfer function. Okay, I thought it is very easy to understand, and in the next video I will discuss uh, for this transfer function what will be the bode plot and transfer function. If anything wrong or silly mistakes in this discussion, then you will correct me in the description. Thank you.